Smith, Extension Field Crops Pathologist for the University of Wisconsin-Madison. You've probably already seen our video on how to actually use the Sporecaster smartphone tool, but I'd like to take a little bit of time just to tell you about some of the biology and some of the assumptions we make in order to make that tool work. Let's start off by actually looking at the white mold cycle on soybeans. So we'll start here in sort of the mid portion of the soybean season, where we have the development of these little mushroom-shaped structures. We call these apothecia. These apothecia actually form from a survival structure, which we call a sclerotium. These sclerotia actually are in the upper soil profile in these soybean fields, and when the conditions are right and the canopy is mostly closed in soybeans, the apothecia actually form. The reason why these are so important for formation is because all the infections really in soybean fields come from these airborne spores that are developed on the inside of the cup of this mushroom. And these spores are forcibly ejected into the canopy and specifically land on the flowers in soybeans and then grow down into the stems. So this is how we get that damage. And one of the frustrating things that happens in soybeans is the time from infection to when we actually see symptoms can be very long, maybe 14 to 21 days. And farmers really would like to actually wait to see how much white mold they have to decide whether they're going to put a fungicide application on. But really at that point, it's too late. You actually need to be applying your fungicides way back up in here where we actually have that infection occurring and protecting those flowers with your fungicide application. Once that plant is colonized, it'll eventually die, and the development of sclerotia will form on those plants. And then when we run our combines through the field, obviously we redistribute sclerotia on the surface of the soil. Now, some of the critical assumptions we make in Sporecaster revolve around the formation of this apothecia. So apothecia are really critical in the development of Sclerotinia stem rot or white mold in soybeans. Without airborne ascospores, we won't get infections in soybean. And the majority of those infections happen through those flowers. So if we can predict the development of the mushroom, and we assume that there's actually spores flying around when those mushrooms are present, then we could better time our applications, especially when that whole process aligns with bloom in soybeans. Just to graphically depict what I'm talking about here in terms of this really critical assumption, here's some trapping data and scouting data where we've actually looked at how many apothecia were in a particular field and then looked at the ascospore flights relative to when we see apothecial development. So in the blue bars here, we have the apothecial counts or the mushroom counts, and then the line here is the ascospore flights in terms of trap catches. And we have aligned the soybean growth stages in this particular field from V4 over to R3. And you can see as we get apothecial formation, we get a subsequent rise in ascospore trapping. And then as those apothecia subside or we can't find them anymore, you'll see that the average number of ascospores actually decline almost to zero. So this assumption that we actually have to have the apothecia there in order to have ascospores seems to hold. And so this is how we're actually using Sporecaster. We're trying to actually predict the presence of those apothecia. We use weather information from the cloud, specifically the Dark Sky API, to actually pull weather that's GPS corrected to your location into the Sporecaster tool. The Dark Sky API is simply a weather aggregator. So they're pulling in various models into their system, and then they're interpolating those models together to give us a GPS grid somewhere between 2.5 and 5 kilometers, where that weather is pretty specific for that particular location. And we're utilizing that GPS corrected weather information and aligning it with our model to see what the risk of that apothecial development looks like. I'll just show you graphically what our non-irrigated apothecial model looks like. So this is the probability of presence here, and you can see as the maximum average 30-day temperatures starts to decline, specifically less than about 82 degrees, we get a pretty high probability of apothecial formation. We also use wind speed in this particular model to actually correct or offset a bit that maximum air temperature, but it's really all about air temperature and whether we're in that right range in order to have apothecial development. And then we're using that wind speed as sort of a drying component to further augment those probabilities. So it's a pretty simple idea, and we do run multiple models depending on whether you're in an irrigated field, non-irrigated, and whether you're on a narrow, say 15-inch row spacing versus 30-inch row spacing. Just to show you what some of our back validation work has shown us, here we have 4 different locations here, a couple from New York State, one from Wisconsin, a couple, a site from Sioux, Iowa, just showing you in the gray box where the bloom period was interpreted to be for that particular variety grown in that location. And then we're looking at the blue line, which is our Sporecaster prediction, our probability of apothecial presence, and then we're giving you a red line there that shows you the action threshold set at 30%. So you can actually see in the 2 New York locations throughout that entire bloom period, it was a pretty high risk for apothecial formation in those particular fields. Here in Wisconsin and in our Arlington location, you'll see we went through some times where it was pretty conducive, then not conducive during that bloom period, and then it rises back up again late in the bloom period. And that really aligns with our observations in that particular location. And then you can see the Sioux, Iowa location where we sort of skirted the action threshold a bit, but you can see never really quite gotten to that particular 25% set action threshold. However, you know, when you get kind of closer, I would say that you should go ahead and just probably go ahead and pull the trigger on those fungicide applications. You know, if you're skirting at 23 or 24% risk and your action threshold set at 25, you should probably just go ahead and pull the trigger. I'd like to thank the funders of our app and what we've been doing here with our Sporecaster tool over the past several seasons. And if you have any other questions about the Sporecaster tool or white mold in general, feel free to visit badgercropdoc.com or feel free to get a hold of your local extension agent.